Okay, so 5.1. Last time we just did one example, I think. But we already know it's probably to run on 5.2, the 5-step process. Right? First, we use it to find intervals of increasing and decreasing. That was 5.2. On 5.1, we use the 5-step process to find maximums and minimums. And there's different types of maximums and minimums. Local, which also has another word that you need to be familiar with. Local/relative. That is in an interval of space. It's the highest point, or lowest point. And then over the entire function, absolute or global. You have to be familiar with two different vocabularies. Just kind of like we have two different, we have Newton's and Leibniz's different notations of y prime versus f prime of x. And then we settled on which one we always use. So, be familiar with both. Okay, so do that. That's the first example we did. Okay, for example 2. So, find the extreme value of the given functions. So, does everyone have this? I think everyone was here last time. Yes? Okay, we're going to go through the 5-step process. So, the first step, domain, d of x. Whatever the function is of x on number 2. Cubic. Normally, what's the domain of a cubic? Negative topography. However, if we're closer after the function ends, we have a restricted domain. Bracket 1, 9, 1 to C. Do you have this? Okay. Just going to turn up this just a little bit. Okay. So, part B. After we identify the domain, take the derivative. And that's fine. If you want to take the derivative, then everybody can do the same thing. Have you did it? And actually, maybe that's just fine. That this function is actually called f. Oh. So usually you see red x if it was a y function. So I probably like f prime. Even though we all know it means the same thing, but I try to keep the same function notation. Okay. Let's see. Maddie, what did you give your derivative? You thinking? Yeah, that's right. Okay. Next step. Clarify when it's not that function, it's that prime of x equals 0 or negative. X is undefined. This is a quadratic function now. Are there going to be any something undefined? No, so never. Now, how do you determine when the quadratic is equal to 0? Set it equal to 0. It's not simplify. You have to solve. Simplify is what we do on expressions. This is an equation. You have to solve. How do you solve this equation? Factor. Have you done? Okay, because we're looking for two numbers that multiply to 12 and add to negative 8. And you have 2 times negative 6. That works. Then we apply, that's not your solution yet, we apply the just right over there, second. Zero property. What's the Jasmine? Zero property. Jasmine, how do you apply the zero property? And over here, zero. Yeah. So we take the factors and we go into zero and solve. So this one is positive. This one is positive 6. So those are critical points, or x-intercepts of the quadratic function. So the x-intercept of the quadratic, which is f prime, where are they representing on f? After the x-intercepts, which will write like 0, represent on f. Maximums and mins, because when you're rounding maximum and min, what's your slope? 0, because you're flattening up, so you're back down, or you're flattening up, so you're back up. That's why the derivative's value is 0 there. Okay, after we've done the critical points, fourth step, number line of f prime. And we put those in order 2 and 6. Okay, what do you do now? Plug 2 and 6 in?
No,
Plug other numbers besides 2 and 6 in, right? So let's do 0, you put it into f prime. F prime. So you plug in 0, and you get what sign? Because that's all we care about is the sign. What's between 2 and 6 that we can plug in? 4, sure. 4 squared minus 8 times 4 plus 12. 16 minus 32 plus 12. And there's a negative. Something bigger than 6. 8. 8 squared minus 8 times 8 plus 12. Ooh, so it's essentially at 64 minus 64 plus 12. Positive. So, on 5-2, I know that intervals of increasing and decreasing. That's all this is asking. Let's review. If it's positive, and the interval is increasing or decreasing? Increasing, because the slope is positive. From 2 to 6, is decreasing, because the slope is negative. Here, increasing. Now, in this section, I want maximums and mins and different types, relatives and locals. So, increasing, decreasing. I still have to do my hand so I can visualize that. I increase and then I decrease. Is that a maximum or a minimum? That's a max. And then I decrease and increase. What does that make? A min. Okay, so on our answer, I mean, I have that too big. Maybe I can zoom this out a little bit. It's a little better. I can still see it. Okay, my answer. What are we doing? Relative maxes and mins versus local maxes and mins. Okay, we got a restricted domain. Normally, from A to B to positive, is there an absolute max and min? No, because the graph goes up and down forever, right? So we have a restricted domain, these maxes and mins, we have the absolute. Not at all, so we're just on a snapshot of the graph, because we're not looking all the way from A to B to positive. So we have, what's that function? F, yeah, that has a relative blank, we'll put that in a minute, at x equals 2 because. Good. Changes from positive to negative. We just have to find the value of that blank. Okay, Sammy, how do we find the value of that blank? Not equal to 0. We evaluate the word. Evaluate f of x, you're right, by the f of x. With 2. So essentially we plug in 2 into f. Okay? And it's up here. Okay, what do we get? Oh, not very nice. 40, was it the last one? Yeah. 47 thirds is what you get when you plug it in. With the calculated version, that would be nice. If it's not a calculated version, you're just going to have to do that all by yourself. Okay. Now, oh, that's one. Okay. What do we say for the 6? At the time. Mm-hmm. Negative to positive. Excellent. And then you would take the 6, you put it into F, and you get actually you get 5. Okay, now, there's actually one critical point we didn't look at. Remember, this last time, on the front page, where was it? Maximum minimums. Can't subtract the maximum mins. And the sign changes and the endpoints. Now, the closed interval on the endpoints. So which one had our closed interval? 1, actually. 1 had a closed interval. And then we did we plug in 0. So we actually know it was positive for the 1. So we actually need to find the sign between 1 and 2. Is it still positive? We plug in 1.5. Yeah, it's really positive. But we also have to include the endpoint. So on our critical point, it's added another one. F prime of x is 0, F prime of x is undefined, and we're now to start checking the endpoints if we have a restricted domain. Which means, let's look at what's coming after the endpoint. We really don't care what's before the endpoint, but what happens after the endpoint. After 1 had a plus sign. Does that mean after 1 is decreasing or increasing? Actually increasing after 1. So there's 1, a minimum or a maximum? It's a minimum. But we have 2 different minimums. So we have to determine which one is going to go absolute for that section versus our relative for that section of time. So let's start with the thing again. One more. F of x has a blank, so we can decide which one it is. Minimum of blank at x equals 1 because this is how we can't say there's a sign change, because we don't know, we're not even looking at anything on the left side of 1. Because it does what after the endpoint? Because it increases to the right of the endpoint. Because, and this is f of x, increases after the endpoint. That'd be awesome if you actually read the endpoint of the vocabulary language. Make sure you check the endpoint, you know that's an endpoint, that's important. So, if we plug in 1 into f, minus value, that's a big easy for us to do. Plug in 1 into f minus value, so we can determine which one is our relative min versus which one is our absolute min. So essentially we have 1/3 minus 4 plus 12 plus 5. I think Charlie has one there. Yeah. 14 thirds. oops, no, that's the wrong blank. 40 thirds is over here. So this one was a minimum, and this one was a minimum. One of them have a height of 5, one of them have a height of 40 thirds. What's the decimal for 40 thirds? So we have a concept of what that means. 39 is 39 divided by 3 So I put peanut there. So it means like pretty repeating. So which one's actually the lowest? Level 5 or level 13.3? 5. So instead of relative, we should call this one the absolute. And this one we should call relative. We have to do that in number 1, so we have a closed interval. So we have to worry about it. Okay. I'm going to show you neighbors chapter number 3. The step process. Okay. When you do solve, please do it without a calculator. First, the domain. Which function is this? Can one of them be absolute? Are they the same name? Which one are you? Number 4? Will you include the so you can send it right now? There's one more. Because those are the endpoints, right? And there's one more critical point. Where's your derivative? So, this one's going because of that negative, this is a denominator, which could be 0. So it ended up fine, so that's why the denominators could be 0. Okay. On number 3, here's some really great computations with universe. What's the domain that we got, Vanessa? What's the domain? Mm-hmm. Excellent. You would also say all rooms except for plus or minus 1. They both would be acceptable. And that comes from the denominator. If you factor out the denominator, which is on your papers, you have x minus 1 and x plus 1. Okay? Part B, derivative. You can use quotient rule, or you can do, you take this x squared minus 1 and move it on. If you like chain rule better, as long as you move up to you have a minus 1, it's a chain rule. With the outer function of x to the negative 1, the inner function of x squared minus 1. And decimals to quotient rule. We do quotient rule. And then do chain? Okay, yeah, because it kind of wrong if it's okay. So that's prime. It is still supposed to be equation, but then on one side you have to do the other side. So we're taking the derivative of the right, we have to take the derivative of the left. So we still write f prime of x equals high, minus high, all over, that cancels out. Oh, where did I never do? Minus high, there we go, 2x, there we go, minus 2x all over, x squared minus 1. I think we all have that, all right? Okay, critical points. Critical points. Now we need to check for 3 things. We have endpoints. Now, we don't have a restricted domain, so we don't have to worry about that. That was our last problem. We do sometimes have to worry about that. So now we look at what is the f. F of x equals 0, and when f times f of x with f prime is undefined. F prime of x equals 0. Do we set the whole thing equal to 0, or can we just set the numerator equal to 0? The answer is actually yes to both. If we set the whole thing equal to 0, the denominator goes away anyway. Steps is just taking the numerator, which is negative 2x. So x equals what number? 0. And then it's undefined for the denominator of our derivative is 0. So x squared minus 1, what would x have to be? Plus or minus 1, actually, right? When you solve this all out, you can get plus 1 minus 1. So we actually have 3 critical points. Say. You dream about the chain rule on? Okay, so we have negative 1, 0, and 1 on our sign chart. Okay, what did you get for our sides to the left of negative 1? Positive and yeah, and positive, negative, and then negative. Okay, so we have a sign change at 0 actually, right? It's increasing and decreasing. So that's the maximum. So we have, what do we say? F, F of x. Link at 0 because Because f prime of x is from positive to negative f changes from increasing to decreasing. So for that, f prime of x changes from positive to negative. As long as we say f. Yes. Okay. Also, f of x has a relative minimum where? Never. Why? Because f prime of x never changes from negative to positive. Nowhere. Because f prime of x never changes from negative to positive. So if they ask you to identify all maxes and mins, you can't just talk about maximums I'll just show that way. You can't just talk about maximums, you also have to discuss minimums. If there aren't any minimums, you have to say that. You have to say why you know there are no minimums. Do you like this break right here? Yeah, negative 1. Okay? Number 4 is similar. Number 5, there is a trig. We're not going to be able to do it, but there's a trig function on a closed interval. So when you go to critical points, you don't just find when, in this case it's y prime. Y prime equals 0 on undefined. You also find when y prime, you have to look at the endpoints. Okay, the endpoints. Which, yeah, because you have a closed interval. So you want to look at the endpoints. Alright, so next time questions on 5.1. And I don't think that we do. And you all have the packet, we're doing 5.1 differently than what the book says. It's on this packet, your brothers. So everyone get this packet last time? We're all here? All the directions are on this packet more than what's on the book. Questions next time, and then we'll begin answering. Okay, so I'm going to grade your test. If you did not pass 100%, it'll be on your own time, or in class time, it'll be on your own time to retake it. You can take it 2 more times. 5 versions, I don't want to make a 6th version. And you don't want to go through it 6 times, which is absolutely within 5 times. No. This is the last time, this is the only time we're going to go over the room test. So we don't have to put too much last time. I didn't put my answers in the doc camera. I'm not going to go over them one by one. How is the play coming, you two? Yeah, I'm going to come Saturday night, probably. Yeah, Miss McDonald. So, might as well get my ticket. Oh, there's a poster over here. So it's $8 in advance, 9 at the door. Are you?